When I was a child, there was a lot of snow in Hungary. Um, it was magical when we could see half a meter of snow on the streets. Nowadays, children can hardly see any snow. We know that climate change is closely related to the emission of greenhouse gases. Most of these gases, like carbon dioxide, are produced when generating energy from fossil fuel. We need a lot of energy. We need a lot of energy for our lives, our homes, our industries. That's how we live. We live connected, mobile, and increasingly digital. We all know that. The humankind consumes an enormous 580 million trillion joules of energy. To understand how much that is, this is the energy content of 14 billion tons of oil. In spite of the fact that huge investments have been made all around the world in order to install green sources of energy, more than 80% of the planet's energy consumption is still produced using fossil fuel. Unfortunately, the burning of so huge amounts of fuel has an increasing burden on the planet, and it heavily boosts climate change. Our beloved planet is struggling with the emission of close to 40 billion tons of carbon dioxide every year. And this number is increasing, unfortunately, in spite of global decarbonization goals. To put this into perspective, 7,000 tons of uranium-235 would be able to generate the same amount of energy in a carbon-neutral manner. Moreover, with the fast advancement of artificial intelligence, we will need to produce even more energy. AI requires a huge number of super-fast computers, which require a generation of an enormous amount of energy. So here's the dilemma. We want to live our lives. We want to live our modern, connected, and mobile lives in nice comfort. And still, on the other hand, we want to fight against climate change. Now, is there a solution, or is this problem unsolvable? The answer is clear. We will need to build clean and green sources of energy. Renewable sources like solar and wind power. And hopefully, in the future, fusion energy. On the other hand, there are some challenges that we will need to solve. Solar and wind-based electricity generation networks alone are not able to meet demand 24/7 because they fluctuate with the weather. We know that the sun doesn't always shine and the wind doesn't always blow. That's why we need diverse sources of electricity in our systems, stable power from stable sources. We also need large solutions to store excess energy when there's a lot of production, and then to release it when there's higher demand. There are two different solutions for this. Hydro-pumped solutions and batteries. Hydro-pumped solutions, hydro-pumped storages, are very much geography dependent. On the other hand, batteries on a grid scale are extremely expensive. Scientists around the world also hope that the ultimate clean and stable energy source will be fusion energy. Fusion, which is the energy source of the stars, is produced when two hydrogen atoms are fused together. However, there are some challenges to overcome. One of the main reasons for this is that the fusion takes place in the plasma, which needs approximately 100 million degrees Celsius. ITER, which is the International Thermonuclear Experimental Reactor, is one of the most advanced and ambitious technological projects humankind has ever attempted. It is indeed fantastic and a huge challenge for engineers and physicists alike. But as all revolutionary ideas, it needs time to develop. So what should we do now? In the coming years, we will need green sources of energy to balance the electrical energy systems that will contain an even increasing number of wind turbines and solar cells. We need stable sources for that. I believe that nuclear energy is and will be part of the solution. Nuclear energy celebrated its 80th birthday a few years ago, and this period was full of developments. Today, approximately 440 nuclear power plants operate in the world. Most of these belong to so-called Generation 2 reactor technologies that come from the 1970s and 1980s, however, with various safety improvements. Due to lifetime extension, they might be able to operate for many more years to come. On the other hand, the 60 large nuclear power plants which are under construction in the world today belong to so-called Generation 3 technologies. These designs are safer, more efficient, and are built to extremely strict standards. In some countries, like Hungary, Slovakia, Czech Republic, and France, the acceptance of nuclear energy is wide. And therefore, in these countries, half or more of the electricity generated is produced using nuclear power. On the other hand, in countries, there are some countries in the world where the fear of people is so huge that they shut down their entire nuclear power plant fleet based on fear rather than scientific evidence. As an example, we can mention Germany, where the last nuclear power plant was shut down in 2023. Nuclear energy, on the other hand, is very safe today. Research has shown that the new generation of nuclear power plants, new generation of nuclear reactors, will not be even safer, but also they will solve some of the problems that the earliers had. In terms of technology, the next generation of nuclear power plants represent the next leap forward. In terms of design, they are very different from earlier ones. Some of them use helium as coolant for the reactor core. Some use liquid lead and liquid sodium to cool the core. Others use molten salt. These liquids are at very high temperature, which are able to help industry for certain industrial processes. Some of these technologies use water as coolant, but at a really high pressure where it cannot even boil. And some of these technologies can come in the form of small modular reactors. In spite of their variety, there are some things in common. One is that they're based on cutting-edge engineering and state-of-the-art safety principles. Generation 4 reactors, for Generation 4 reactors, the safety is not dependent on the ability of a technology to operate, as with earlier ones sometimes, but it is dependent on physical principles like gravity and natural circulation. Scientific studies show that the risk that even people living in the immediate neighborhood of a Generation 4 nuclear power plant would be exposed to unexpected radiation is practically non-existent. They have much higher efficiency than earlier generations. Some are capable of producing hydrogen directly, and this supports energy storage. The high temperature output makes them very useful for industrial processes. They produce less waste. Some of them are even able to use the spent fuel from presently generating nuclear power plants. And this turns a problem into a solution. There are Generation 4 nuclear power plants which are able to use the material that once were used for nuclear weapons. And using this, we can produce peaceful energy from weapons. Now, as I mentioned, some of these may come in the form of small modular reactors. These are compact, modular, and flexible systems which can be deployed even in remote areas. And these can actually replace old and obsolete coal-fired power plants. Some of these reactors might even come in the form of microreactors, which are smaller systems producing smaller amounts of energy. If we are serious about solving the climate change problems, then I believe that these reactors are not only a good option, they are essential part of the solution. They're built on decades of research, which is powered by innovation, and they're proven to be extraordinarily safe. Let's support science. Let's stand by and let's invest in the development of Generation 4 technologies and small modular reactors. And in doing so, let's invest in a more stable, cleaner, and more hopeful future for our planet. Thank you very much.